We were looking at fractals in our last lesson, and I wanted to show you what the 9th iteration of the Sierpinski's triangle would look like. This would be a computer-generated example. This is also a student work and then a computer-generated image of that work. But this is the beginning image, and this is the first iteration. And this is the second iteration, and then this is the 11th iteration. There are several different fractals that you could choose to use in your class. This is called the square carpet. So you begin with a square and then you take out the middle, and then you divide this into 9 and you take out the middle, and you continue to do that. That's called the square carpet, and it would look like this after you get to stage 3. So you can call it staged or you can call it an iteration. So this would be an iteration of 3, or it would be the 3rd stage, because this is the beginning stage. So notice they started with it all colored, and then they erased the middle square. Or you can begin with it all uncolored and color in the middle square, which I think is an easier route to follow. This one is called the tree, and you begin with the trunk and 2 branches. Now notice that the trunk and these branches are in a relationship of 2 to 1. So this one is twice as long as this one. So you start out with 1 and you make 2, and then off of these you will make 2 and it will be half as big. So it will be half as long, and you continue like that. So I kind of like the tree. I think that would be easy for students to do. Now this is an example of what it would look like. After a few iterations. It's another variation of that. You start out with a vertical line, and then 2/3 of the way up you make a perpendicular line that is half as long, and then you make, for each of those, you go 2/3 of the way up and you make it half as long, and by the 5th iteration this is what it would look like. This is called Koche's island. It begins with a square, and then you divide this segment into 4 parts, and you cut out this part and move it up here. So this would require some tape and scissors. You do that for all 4 sides. So you're going to cut out, you're going to make this side into 4 parts, cut out this part, and tape it up here. So you're doing that on all 4 sides, and eventually it's going to look something like this. So how did I get that? Well, we're going to do a variation. And it's called Koche's Snowflake. We're actually only going to do one side of that snowflake, because you would start out with a triangle, and then you would do the 3 sides of the triangle, so that eventually it would look like this. But we're only going to do one side, because I think you're going to get the idea without us having to go through all 3 sides. Now you will need a pencil for this activity, because you will have to erase. So let's get some graph paper. We're going to look for a pattern in the perimeter. We won't be able to do area because we're not going to make the whole shape. We're only doing one side. But we will look for a pattern in the number of segments and the length, or I guess it would be length instead of perimeter. This time I think we will make our first segment 9 centimeters long. And again, you need a pencil so that you can erase. Alright, so we're at 9 centimeters, and you'll know why I chose 9 in just a minute. Okay, I'm going to divide this into 3 equal parts. By the way, this is spelled Koche, Koche's Snowflake. So I'm going to divide this into 3 parts. So I'm going over 3 and over 3. I'll call that C and D. So now when I make my table, I'm going to have the stage. I'm going to have the number of segments. I'm going to have the length of each segment. And then I'm going to have the total length. So at stage 0, there is one segment that is 9 centimeters long, and of course that's the total. you're going to erase CD. I'm going to use my compass and make a radius of CD. I'll make a circle at C and a circle at D. I'll connect C to that intersection point here and here. And I can call that E. This now is stage 1. In stage 1, I now have 4 segments. Now this little fella right here is gone. And this is 3. So are these 3, because I made them the same as CD, which was 3. So 3, 6, 9, 12 is the total. And the length of each one is 3 centimeters. Now I'm going to help you begin with stage 2, and then I'm going to have you do stage 3 by yourself and then look for a pattern. For every segment that is left, AC, CE, ED, and DB, we have to do exactly what we did for stage 0 or stage 1. I'm going to divide AC into 3 equal parts. I'm going to erase the middle. I'll use my compass and make a radius of 1 centimeter. And then I will make a circle, and at that intersection, I will connect to here. Now you will have to do the same thing here. You need to measure 1 centimeter and mark that here so that you'll know where to cut out that middle segment. So you're cutting out the middle segment here, cut it out or erase it, and then you're going to make another segment that's 1 centimeter here. You'll do the same thing here and here. Now on your 3rd iteration, it gets a little tough because it gets kind of small, but for every segment that you have to divide it into 3 parts, take out the middle, and make a V. So for every segment that is there, you will make the same process that we did on iteration 1 and iteration 2. So in filling out your chart, I want you to finish the second iteration, do the third, and then see if you can make a conjecture. Now a hint, anything to the 0 power is 1. So if I have 10 to the 0 power, that's 1. Or 7 to the 0 power is 1. Or x to the 0 power is 1. And so that's going to help you in coming up with a pattern, I think, for the number of segments. So finish up Koche Snowflake, finish up your table, and make your generalization.